and done negative 999 to 0.833. So I could have done this, which I showed you how to do earlier, second distor. And some of you guys, when I was doing this earlier, probably said, hey, can't we just do it this way? Yes, you can. Okay, but I want you to get an understanding of what this means. And that's going to be 0.798. And then if you remember, 798, it was 1 minus 0.798. 1 minus 0.798, and I get 0.202. And that's what I got above. Okay? So I want you guys to try this one. What percent of Rafael Nadal's first serves are between 100 and 110 miles per hour? Please pause that. Okay? Pause that. And I want you to give it a shot, and then we'll go over the answer. All right, so we're back. We're back. So between 100 and 110. So here's 100. Here's 110. I'm sorry, 100's over here. 100's down here. 110 is there. And I want to find out this area. So I have it drawn. I'm looking at that area. I got to find z-scores for both of those. So again, z is x minus the mean divided by the standard deviation. So it's going to be 100 minus 115 divided by 6. So it looks like I get negative 15 over 6. And 15 divided by 6 is going to be 2.5. So that's going to be negative 2.5. And then the other one's going to be 110. 110 minus 115 divided by 6. So it's going to be negative 5/6. Well, 5/6 up here was 0.833. So this is going to be negative 0.833. So I have to go from here to here. So I'm going to do second distor, norm CDF, negative 2.5 to negative 0.8333. I could keep going with the threes if I wanted to. And I'm going to get about 19%. So about 0.196, actually about 20%. Okay, so it looks like we have one more example on this page. And we will do that, and then it'll be the end of chapter 2. Good stuff. At this point, it is August 27th, my second day of work, and I have no idea how we're going to quiz and test. So I'm hoping to figure that out in the next couple days, because that's really important. So for this one, my mean, it's normally distributed, normal distributed, 94.5, comma, 4. Okay, so remember that's mean, that's standard deviation, and capital N stands for normal. So I'm going to draw myself a little picture. Okay, and I put the middle, and I cut off the tails, and I split the uprights, and this is 94.5. And if I want to go up 4, that's going to be 98.5. And if I go up 4 more, it's going to be 102.5. If I'm at 94.5, oh, not 5, 4. Oh, I think I did it right. Go down 4, this is going to be 90.5, and this is going to be 86.5. So they want to know the third quartile. What does that mean? What's the third quartile? Anybody? The third quartile. That means it's at the 75th percentile. Okay? So I can't put in a percentile. I have to put in a z-score. Okay? So what do? I'm going to give you guys a little bit of time to think about that. The 75th percentile. So I have to take the 75th percentile, and I have to go in and I have to find a z-score for that. Okay? And then once I find that z-score, then I can take it and I can go and plug that in. So let's find a z-score for the 75th percentile. Well, if you remember your flow chart, we have x, we have z-score, and we have percentile. And if we go underneath from percentile to z, we use what's called inverse norm. Okay, inverse norm. So I go second dister. I go down to inverse norm. I want the 75th percentile, 0.75. And the z-score for that is going to be 0.674. Okay, so my z-score is 0.674. Now, they want to know what's the third quartile of this distribution. So what they really want there is they want you to come up with a data value. So we're going to say z equals x minus the mean divided by the standard deviation. Z is 0.674 equals data value, we're looking for that. The mean we know is 94.5, and we're dividing by that standard deviation, which is 4. So now it's a math problem. We take this times this, 0.674 times 4, 2.696, and I add 94.5. And I got 97.196. 97.196 is the data value. Okay? So what are we talking about here? We're talking about heights of 3-year-old females. So we would say something like the third quartile of 3-year-old females' heights is, and then I'd say 97.18, and then it's going to be in, I think, centimeters. Okay? Or what we get, 97.196. All right? That wraps up chapter 2. We can look at this. This is just some notes. You know, we talked about SAT scores and IQ scores being normal. Some things that are non-normal, personal income, we talked about that already when we in chapter 1. Survival times of cancer patients. Everyone reacts to medication differently, and everyone has, you know, different levels of the cancer. Lifetime of electronic devices doesn't follow a normal model. Okay, so you need to develop a strategy to assess if something's normal. If the graph is clearly skewed, has multiple peaks, or isn't bell-shaped, then it's not normal. Just because the data looks normal, we can't say it's normal. Okay, so you probably have some of these multiple choice questions at the end of this packet to practice with. This is good practice, and it's easy. So you just sit here, you draw your little normal model, and then you pump out some of this stuff, because I'm telling you, if you get a good foundation with this stuff, it's going to help you in chapter 7, chapter 8, chapter 9, 10, and maybe even 11. All right? That's that, guys. Talk to you soon.